Okay, in this video we're going to continue with exam 3, and I'm going to start with question number 6. As you can see, it is a fraction that needs to be simplified because it's got a radical in the denominator. This is called rationalizing the denominator. To rationalize this kind of problem, because we have that 3 minus the square root of 2 there, we're going to have to multiply this by the conjugate, which is going to be 3 plus the square root of 2. And that's a form of 1, so anytime we multiply something by 1, we get an equivalent answer. So we're not really changing the value of this, we're just changing the looks of it. When you multiply conjugates a plus b, a minus b, the product is a squared minus b squared. Now you're free to FOIL this out if you'd like, but using that template, a squared minus b squared, is a little bit quicker, so that's what I'm going to use. When I square the first components, I get a 9. And when I square the second components, I get the square root of 4. And we'll come back in a second here and clean that up. In the numerator, I'm just going to, for right now, put them over the same division bar and maybe come back later and clean this up. But let's go ahead and finish up the denominator. The square root of 4 is obviously 2. So when we subtract it from 9, we get 7. Okay, so in this case, we can't cancel anything out or reduce this any further than what it already is, because if we could cancel out a factor between 6 and 7, but that's not going to happen because there isn't one. So simply distribute that 6 into the problem, and you're going to get 18 plus 6 times the square root of 2 over 7, and that's going to be your answer. Okay, let's look at question number 7. We're asked to solve it. You'll notice here there is no linear term, and when there is no linear term, you can isolate the quadratic term, which is b squared. So I'm going to do so by subtracting off the 7 from the left-hand side, and that's going to give me b squared equals -1. And we're going to, again, solve for b. So we're going to take the square root of b squared, and what we do to one side, we're going to do the other. And this should become a familiar to you. This is an imaginary number. So we get the positive and negative value of I there, because we're going to trade that out for its equivalent, which is I. So your answer choice there is going to be letter A. Now with question number 8, what I've done is I've kind of rewritten it vertically instead of horizontally, and I've lined up my like terms. Since this is an addition problem, I don't need to change any of the signs. I just simply need to go through and add these. And when I do, I'm going to get 10r to the 4th plus 5 plus 10r squared. And if you were putting this in proper form, you may want to put that 10r squared second and the constant last. And that would be your answer. Okay, let's take a look at question number 9. Question number 9 is asking you to use the remainder theorem to evaluate the expression at the given value. So let's go ahead and do that. And first thing I'm going to do is remove all the variables and just write the coefficients. And I don't need to put that plus there. Let me back up. So it's going to be 8, 11, and -9. And for what you need to do too, folks, is just make sure you don't have any missing terms. So you start with a countdown, 3, 2, 1, constant. We're in good shape. And now the number that goes in the corner is the -3. We're not going to change it out because it is already solved for n. And with synthetic division, we're going to drop down the first term and start multiplying. These two multiply to equal -3. When we add these together, we get 5. Multiply these two out again, we get -15. Add, we get -4. Multiply these out again, you get 12. Add these together, you get 3. And since we are using the remainder theorem says look at the remainder. Well, the remainder theorem in the synthetic division problem is the very last number. So if I were to run that -3 through this problem, the answer would be 3. Okay, finally, let's take a look at number 10. 10, we're asked to write a polynomial function of least degree with these zeros, these given zeros. So these are the zeros, so let's work backwards a little bit. So if that's a 0, then the factor was x minus 1, and x minus 4, and x minus 5 were the factors to get me those zeros. If you take a look at this, you can see if you put a 1 in there, you get the 0. If you put a 4 in there, you get the 0. If you put a 5 in there, you get a 0. So that's simply how you do it. Now to write a polynomial function, you want to multiply these out. And so you do so by taking 2 at a time. And it really doesn't matter which 2 you start with. So I'm going to begin with the latter 2. And I'm going to use the FOIL. So I'm going to get x squared minus 5x. Distribute the negative 4, you get minus 4x. Negative 4 times negative 5 is positive 20. And next I'm going to just simply clean up this problem because that's equal to x squared minus 9x plus 20. And now I'm going to distribute this binomial into this trinomial. And I'm going to do that by starting with the x and distributing it down the line. So when I do so, I get x times x squared, which is x cubed. X times negative 9x is negative 9x squared. X times 20 is positive 20x. Next, I'm going to move over to the negative 1 and do the same thing. Negative 1 times x squared is negative 1x squared. And again, you'll notice I'm doing this vertically because it's just easier to simplify in the end. A negative 1 times a negative 9x is a positive 9x. And a negative 1 times a 20 is a minus 20. And now when I combine these two lines, I get x cubed minus 10x squared plus 29x minus 20. And that is your answer. And that does conclude this video.